Hey there, welcome to lesson 1 of calculus. So please turn to the first page, and today we are doing the average rate of change. I'm going to give you a second to go ahead and read the first part here up to example 1. Go ahead and pause the video, read that, and then when you're ready, there's a couple things I want to highlight. So go ahead and read that. All right, so a couple of things. This is the average rate of change of 2 points. So basically this is slope of a line. You guys know this, change in y over change in x. We're calling the change in x h. So h is basically the distance between our two x values. It's always going to end up being h on the bottom because they're h apart. So when you subtract them, you get h. So we have 2 points, P and Q. Don't let this confuse you. It looks a little bit confusing. It's basically just the x and y value for P, the x and y value for Q. Those are just 2 points on the graph. We're finding the slope in between them. So we have our secant. That's just the line between the 2 points. It's a secant because there's a curve. So it's kind of slicing between the curve. And then this is where things got a little bit confusing here in this second paragraph right here. So what we're basically saying is if we take Q and we just slide it down to P, so we're closing the gap between P and Q. We're narrowing it down until it's 0. When we slide Q down to P, what happens to our secant is it becomes a tangent because it's only going through P since Q is now basically on top of P. And it's really important to remember when we do that, our h, which is our distance between our 2 points, becomes 0. Okay, so we're finding in this next few examples, we're going to be finding the equation of the tangent line. Okay, all right, so let's look at example 1. It says find the slope of the parabola y equals x squared at the point 2, 4. So we're finding the equation of the tangent line at that point that is on the parabola. Okay, so let's start by sketching the parabola on the graph. So just sketch y equals x squared. And we're going to be finding the slope of the tangent line at 2, 4. We're calling that P. All right, so the way that we're going to do that is above we talked about having this second point Q, and we're finding the slope between P and Q, and then we're bringing Q, basically sliding it until it's on top of P. So we're going to go ahead and give ourselves Q, and Q is going to be H away from P. So we have this second point, P, the x value is 2, Q, the x value is going to be 2 plus H. It's just H distance away from P. To find the y value for Q, remember my formula of this parabola is x squared. So whatever the x is, to get the y, I square it. So my y value is going to be 2 plus h squared. All right, so I'm going to go ahead and find the slope between these 2 points, P and Q. So I'm going to do the change in y over the change in x. Okay, so I'm going to subtract my y values. So my first one I'm going to do is the q y value. So that's 2 plus h squared minus my y value of my p, which would be 4. Okay, and that's going to be over the distance or the change in my x. So my q x value is 2 plus h minus my p x value, which is 2. All right, let's go ahead and distribute out the 2 plus h squared. So that gives me 4 plus 4h plus h squared. And then I have the minus 4 at the end over 2 plus h minus 2. So my 4's will cancel, my 2's will cancel. So I have 4h plus h squared over h. And I can actually cancel an h off of everything here. So I wind up with 4 plus h. All right, so the slope between P and Q, and remember Q is just some point that is h away from P on the x-axis. My slope between those 2 points is 4 plus h. So remember, we are sliding this imaginary point Q, we are basically sliding it to P. So what's happening to our h is our h is going to become 0. Our distance between P and Q is going to become 0. Okay, so let's write this down. As Q approaches P, the distance between them which is the change in x, or h, becomes 0. So our 4 plus h becomes 4 plus 0. So it's just 4. So what we just found is we found the slope of the tangent line at this point P. So to find the actual equation of the line, I also need the y-intercept, which is my b. Okay, so my m is 4, and I'm going to use the point P now. So P is 2, 4. And that's going to be my x and my y, and I'm going to solve for b. So I'm going to do y equals mx plus b. And I'm going to plug in for y, I'm going to plug in 4. For m, I'm also going to plug in 4. For x, I'm going to plug in 2. So I get 8 plus b. And so my b is negative 4. Okay, so my equation of the tangent line at P is y equals 4x minus 4. All right, I'm going to apologize right now. I'm aware that I did not give you guys enough room on this problem. I am sorry. All right, I'm going to graph this line really quick so you guys can see how it looks on the graph. So it starts at negative 4 and goes up 4, right 1. All right, let's try another one of these just to practice since this is kind of a new concept. So looking at number 2, it says write the equation of the tangent line to the curve f of x equals 3 minus 4x squared at the point 1, negative 1. So the first thing we do is we give ourselves a second point. We're going to call it Q. And the point Q is h away. So this point is at 1. Our point Q is going to be at 1 plus h. So I'm just picking a point that's h away. So 1 plus h. And then remember, to find your y value for the Q, you're going to plug your x value into your function. So this one's going to be 3 minus 4, and then I'm plugging in the 1 plus h for x. So 3 minus 4, 1 plus h squared. All right, so I'm just going to go ahead and work that out over here. I'm going to distribute the 1 plus h squared and then combine like terms. So let me work that out now. All right, so the next thing I'm going to do is find the change in y over the change in x, so the average rate of change from P and Q. So I'm going to do change of y over change of x. So my difference of my y values. So I'm going to start with my Q. So my Q y value is the negative 4h squared minus 8h minus 1. Subtract my y value of my P, so that would be negative 1. And then on the bottom, I have the difference of the x's. So my qx is 1 plus h minus my px, which is 1. So here my negative 1's are going to cancel, and then my 1's are going to cancel here. So I get negative 4h squared minus 8h over h. Spoiler alert, the denominator will always be h because these points are h apart. So when you find the difference between them, it's always h. All right, we can cancel an h on everything. So we get negative 4h minus 8. So as we bring Q to P, the distance h between Q and P is going to become 0, okay? I'm basically just sliding them together so their gap between them, which used to be h, is going to be 0. So my slope, when I plug in 0 here, is negative 8. All right, now we're going to use our point P, 1, negative 1. That's going to be our x, y. And now we're going to plug them in to find the b. So y equals mx plus b. My y is negative 1. My m is negative 8. My x is 1. So that becomes just negative 8. I'm going to add the 8 over to the other side, and I get 7. All right, so my equation of my tangent line at point P is y equals negative 8x plus 7. All right, when you are ready, we are going to turn the page. So number 3 says the figure below shows how a population P of fruit flies grew in a 50-day experiment. The number of flies was counted at regular intervals. The counted values plotted with respect to time t, and the points joined by a smooth curve. Find the average growth rate from day 23 to 25. So we're basically just finding the average rate of change, which is the slope of the line between these 2 points. They've actually labeled them for us, P and Q. So I have my 2 points, P, which is 23,150, and Q, which is 45,340. And I'm just finding the average rate of change, so the change in y over the change in x. So I have 340 minus 150 over 45 minus 23. So this gives me 190 over 22, which is about 8.6 flies per day. All right, number 4. On number 4, we are just finding the average rate of change of the function over the given interval. We're just doing change in y over change in x. Notice here, I have not given you a single point. I've actually given you an interval. So both of these are x values, 2 and 3. And so we actually have to plug them in to find the y values. So let's do that first. So first one would be 2 cubed plus 1, that's 9. And then 3 cubed plus 1 is 28. So when I do my change of y over change of x, I would do 28 minus 9 over 3 minus 2. So I get 19 over 1, which is 19. All right, on B, a little bit more complicated because it's a trig function. So I have my pi over 6 to pi over 2. I'm finding my average rate of change of the cotangent of t. So I'm actually going to start by writing down my t chart on this one. And I only care about the pi over 6 and the pi over 2. So I'm just going to do those 2 points. And when you do cotangent, cotangent is going to be the reciprocal of tangent. So tangent is y over x. So cotangent will be x over y. All right, so when I do the cotangent of pi over 6, that's going to be radical 3 over 2 over 1/2. I'm just doing the x over y for that point. The 2's can cancel, so I get radical 3. For cotangent of pi over 2, x over y, I get 0. All right, so let's do our change of y over change of x. So I would have radical 3 minus 0 over pi over 6 minus pi over 2. So on the top, I get radical 3. On the bottom, I need a common denominator, so I'm going to multiply by 3. So I would get negative 2 pi over 6. I can reduce that. And then I'm just going to flip that bottom fraction to bring it up to the top. So I will get negative 3 radical 3 over pi. I'm trying to. All right, thank you guys for watching lesson 1. I hope that if you have any questions, just jot them down in your notes and we can talk about them in class. All right, I'll see you guys soon.